record. All right, my friends, we are recording. Okay, let me come back and let me see. That was not us. That was not us. Here we go. This was us from the other day. Okay, so y'all, what we're going to do today, we're going to go through 4.2. Okay, 4.2, my friends, talks about this idea called binomial distributions or binomial experiments. So, y'all, in binomial experiments, we're only going to have two outcomes, either a success or a failure. Okay, so a binomial experiment satisfies the following conditions. Number one, the experiment is going to repeat it for a fixed number of trials. So we're going to perform this thing 5 times or 7 times or 1,006 times, something like that, right? There's going to be a certain number of tries we're going to do this. The second thing, y'all, we only have two possible outcomes. Either it's a success or it's a failure, okay? The probability of a success is the same every time we try this. Okay, so my probability does not change. It needs to stay the same. And there's something we're going to call a random variable x. That's going to count the number of times we were successful. Okay, so y'all, we have some symbols up here. Here are my symbols. Okay. So the letter N tells me how many times are we going to try that experiment. The letter P stands for the probability that it's going to be a success. The letter Q is the probability that it's going to be a failure. And the letter X stands for the number of successful trials. Okay. So y'all, let's see if we can figure what we're talking about here. It says, decide whether the following is a binomial experiment. And if it is, if it is, specify the values of N, P, and Q, and then list the possible values for the random variable X. If it's not, tell me why. Okay, let's go through it. It says about 50% of babies are born with a certain ailment recover fully. A hospital is caring for 6 babies born with this ailment. The random variable represents the number of babies that recover fully. Decide whether this experiment is a binomial experiment, and if it is, identify a success, specify the values of N, P, and Q, and list the possible values of the random variable X. Okay. In order for it to be a binomial experiment, we have to, number one, repeat it for a fixed number of trials. So y'all, what we mean by a fixed number of trials, we have these babies that are born with something's going on with them, right? And they're all in the same hospital. How many babies do we have at this hospital right now? Anybody know? I'll give you a hint. It's going to be somewhere in this paragraph. How many babies are there? 6, right? Okay, look, y'all. So my number N is the number 6. We're going to try to cure each of these 6 babies, okay? The probability that we can cure them. So the probability that they're going to get cured, y'all, what's the probability that they're going to get cured? 50%. As a decimal, everybody agree 0.5? Okay. Y'all, remember what we said the other day? If Tim Smith says there's a 50% chance that it's going to rain, what's the percent chance that it's not? It would also be 50%. That's the probability that they don't get better. Okay, we hope that they do. All right, X. X is the number of trials. Now, y'all, we have 6 babies here. What I want you to think about, y'all, is there's the possibility that all 6 babies fully recover, right? We got all of them. There's a possibility that only 5 get better, right? There's a possibility that 4 get better. Do you see the game that I'm playing? Where do you think I'm going to stop counting? Could we go a little further than that? Could it be possible that none of the babies get better? Right? So guys, we're going to go from 6 all the way down to 0. Or we could say we can go from 0 to 6, right? There's a chance that none of the babies recover. We obviously don't want that. The best outcome we could hope for is that all 6 do. So my values for X here, y'all, are going to be no babies get better. 1 baby gets better. 2, 3, 4, 5, y'all, all the way to 6. Okay. So first thing I'm going to do, is it a binomial experiment? So far, my friends, I'm going to say yes, right? This is a binomial experiment. Okay. What is a success in this experiment? We are obviously hoping that what happens here, y'all? The baby recovers, right? Boom. That's what we want. We want the baby to get better, right? Okay. Sorry about the way the copies came out, y'all. The thing came out on the next page. Remember, we talked about this right now. Specify the value of n. N was the total number of babies that we had. What was the total number of babies we had? 6, right? The probability that they were going to get better, everybody agree, was 0.5, right? 50%. Yo, for the values of P and Q, even if they give it to you as a percent, they're going to ask you to write it as a decimal. Okay, so that's why I'm going 0.5. And in this case, isn't my Q also 0.5, right? And then, y'all, my letter X could be all the possibilities that we could have. Wouldn't it be, let's see, what's the difference between these two here? This one doesn't have 0. There we go. So, y'all, we want the second choice. We want B, right? Because we want to go 0 all the way to 6. This one only saying that only 5 of the babies got better. We would like all of them to get better. So my possible choices for X, y'all, is that would be these guys right here. Okay. So y'all, all we're trying to do in these couple of problems is, hey, is this a binomial experiment or not? Okay. A couple things have to happen. We have to repeat this. We have to have a certain number that we're looking at. Okay. My probability has to be the same every time. And what else did we say? Scroll back. What else did we say? Probability. We got to be able to find the probability of that it doesn't succeed, which is just 1 minus, right? Like the Tim Smith kind of thing. And then my number of trials, y'all, is always going to be 0 all the way up to the value of n. Okay. Let's take a look-see at this question here. Okay. A survey asks 1,400 workers, has the economy forced you to reduce the amount of vacation you plan to take this year? 48% of those surveyed said they are reducing the amount of vacation. 20 workers are participating in the survey are randomly selected. The random variable represents the number of workers who are reducing the amount of vacation. Decide whether this is a binomial experiment. If it is, what's the success? What are the values of N, P, and Q? And list the possible values for the random variable X. Okay, so look, y'all, I'm going to come back over here. When I read through this question, y'all, there's a lot of information here. We looked at how many workers? 1,400, right? But then what we did from that point, y'all, is we said out of those 1,400, we're just going to focus on these 20 people right here. Okay, so look, y'all, number one, my N is not really 1,400. It's the 20 that we're focusing on. Okay, we're going to figure out how many of those people said, yes, I am reducing the amount of my vacation. Y'all, what percent of those people said that they are reducing the amount of their vacation was? 48%. Y'all, as a decimal, do you guys agree that's 0.48? Okay, let's see if we can find our value of Q. Y'all, if Tim Smith said there's a 48% chance that it's going to rain, what's the percent chance that it's not? 52? Everybody agree? Because it has to add up to how much again? 100%, right? Okay, very good, y'all. Okay, y'all, we are asking 20 people. It's possible that out of those 20, none of them reduced their vacation, or one of them, or 2. Y'all, I'm going to keep going all the way till I get to what number? To 20, right? Boom. Do we got a binomial experiment? Yes, we do. Okay. Y'all, what is the probability of success? Let's come back here. Let's make a look. Let's take a look right here, y'all. 48% said they are what? What are they doing? Reducing their vacation. So y'all, look, I'm going to go with choice A. Boom. That's the success because that's what we want to know. Okay. Let's come back down here. All right. So look, we already answered this kind of, but let's come back and let's fill in the blanks. Out of those 1,400, we looked at how many specifically? 20. Here's my 20. Oops, sorry, that looks like a messy 20. Let's fix that. Boom, 20. The probability, wasn't that 0.48? For my Q, that was a 0.52. And then we said we're going to go from what to what, my X? 0 to 20. There you guys go. Boom. You're done, my friends. Okay. So, y'all, this is how we figure out whether it is a binomial experiment. Now, what we're actually going to do is we're going to find those probabilities. Y'all, there's something called a binomial probability formula. And the binomial probability formula is this guy right here. Y'all, we've been talking about how to use that combination button. So that combination button, boom, it's right there. So we're going to have the number of trials. We're going to choose how many are successful. Then we're going to take our probability of success, we're going to raise it to the power of X. My probability of failure is going to be raised to the power n minus X, okay? So look, y'all, I'm going to scroll down. Actually, you know what I'm going to do before I scroll down, Charlie Brown? I'm going to come back right here, y'all. Boom. It's from another class that I had last night. I'm going to copy this dude right here, y'all, okay? The reason I'm going to copy this guy, y'all, I'm going to be using that formula as we go through. And it's going to be easy breezy cover girl if I got access to it, okay? Let's take a look here, y'all. Let's see. Oh, look, there it is right there. Okay, let's take a look at this first question. 39% of U.S. adults have very little confidence in newspapers. We randomly select 8 U.S. adults. Find the probability that the number who have very little confidence in newspapers is, part A says exactly 6. Okay, let's break a couple of things down here, y'all. The first thing we're going to do, we're going to look for a value of n. How many people did we randomly select? 8. Boom. Okay, let's find our value for P. What's the percent of people written as a decimal that say, you know what, I'm not sure what was written in the newspaper was accurate? 0.39. Okay, y'all, I got a question for you guys. Anybody know what the value of Q would be? 0.61. Marissa, if you don't mind me asking you, how did you get that 0.61? You subtract it, right? 1 minus 0.39, right, y'all? Tim Smith says, hey, 39% chance it's going to rain. You're like, yeah, but that means a 61% chance that it's not. Okay. Now, for part A, y'all, it says find the probability that the number who have very little confidence in newspapers is exactly 6. For part A, y'all, my X is going to be 6. Okay, let me show you what we're going to do here, my friends. We're going to come back here. We're going to look for the probability of 6, okay, because that's my X value. Look at the first part of the formula, y'all. The first part of the formula has that n choose 6. We already said that our n was 8. So look, y'all, I'm going to go 8, choose 6, okay, times, I'm going to put this guy in parentheses. Y'all, we're going to multiply by my probability, my p-value. Our p-value, y'all, was a 0.39. We're going to raise that to the power of X. Our X, y'all, here was the number 6. Then we're going to take the probability that they did have confidence, the Q, the 0.61, and we're going to raise it to the power n minus X. N was 8, X was 6. Excuse me. Y'all, I want you to do something for me real quick here. What's 8 minus 6? 2. So y'all, I want you to think about it like this. If we're looking for 6 people who believed that 39%, doesn't that mean that the other 2 believe the 61% is their probability, right? Because we're looking at 8 folks in general. Okay, y'all, this is what I'm going to do. I'm going to grab my calculator right here. Okay. Y'all, again, if you need to, open up your computer. I want you guys to get familiar with using the calculator. A big part of this, what we're going to do today, y'all, and when we come back after our first test and we're doing chapter 5, a big part of it is going to be calculator work, y'all. And unfortunately, for this problem here, guys, I can use this one. It'll work. But in a minute, I'm going to show you a feature on the calculator that I can do on this one that I can't do on that one. Okay, so I want you to get comfortable with this because at some point, I'm really going to tell you guys, y'all, I think this is the way to go. Again, you can download one of those apps, but I think this is the way to go. So look, y'all, I'm going to drop some parentheses. I'm going to go 8 math. We're going to come back to our probability. We're going to do number 3. We're choosing 6. Okay, sorry, I'm trying to keep everything on the same page so you can see it. Okay, then y'all, I'm going to come back again. Oops, sorry. I'm going to come back again. I'm going to drop some parentheses. Let me see if I can do this. Boom, boom, boom. There we go. Okay, and I know it's a little hard to see, my friends. I apologize. I'm going to go 0.39. I'm going to raise that, y'all, to the power 6. I'm going to scooch over. I'm going to drop some parentheses again. I'm going to go 0.61. I'm going to drop that here. And we're going to raise it to the power of, we said 2. Okay, and then, guys, I'm just going to hit enter. And, y'all, I'm going to show you something right here on my notes. It's telling me to go to 3 decimal places. Y'all, 3 decimal places. Would you be hitting 0.036 or 0.037? 37. All right. So boom, y'all, right here, we're going to drop in a 0.037. And we found it. Okay. Y'all, we're going to repeat that same process. Okay. We're going to do this again, but now we're looking for the probability that people who have very little confidence is exactly 2. So y'all, what we're really looking for here is P of 2. Okay, I'm going to kind of zoom out a little bit so you can see everything here. So the first part says, oh man, sorry guys. The first part says we're going to do 8, choose 2. Okay. The next part says we're going to take our P number. My P number, y'all, was a 0.39. We're going to raise that to the 2. And then we're going to take our Q number, 0.61. Y'all, remember right up here, it says we're going to do n minus x. Y'all, what's 8 minus 2? That's the number that's going to go right there, right? All right. Y'all, I'm going to do the same thing I did before. Now, guys, there's something that these calculators kind of do for us. I want you to notice what we typed in the first time and what we're doing the second time. Y'all, from this line right here to this line right here, what's the only thing we really changed? Isn't it really just my exponents? Like the 8, I'm sorry, this is also changed too, right? Instead of a 6, this is now a what? A 2. And instead of a 6 here, this is a 2. And instead of a 2, that's a 6. Y'all, one of the things that these calculators do, if you hit the button that says second, and you hit the button that says enter, it types in exactly what you typed in before. And then if you want, you can use your little arrow button to scroll back, and where that 6 used to be, put a 2 there. Scroll back over here, where that 6 used to be, put a 2 right there. Scroll over here, where that 2 used to be, put a 6 right there. And you don't have to type in the whole thing all over again. Boom. And y'all, I'm going to go ahead and go to 3 decimal places again. And what do you think? 0.219 or 0.220? 219, right? So y'all, again, there's just certain little features, 0.219. There's just certain features that graphing calculator has, y'all, that I think makes some of this a little easier to do. Okay. All right, y'all, I'm going to scroll down a little further, and we're going to create what we call a probability or binomial distribution here. Okay, so let's kind of scroll right here so we can kind of get everything on the same page, and we'll go through slowly, my friends. 34% of voters think that Congress should help write standards for school food. We randomly select 6 voters and ask them, hey, should Congress help write these standards? The random variable X represents the number of voters who think Congress should help write these standards. Okay, so y'all, we're going to do a couple of things here. Okay, first thing I'm going to do, sorry, let me do this real quick. Boom, there we go. All right, let's get some information here, y'all. How many people did we ask? 6. And here's my N. Boom, my N is the number 6. Okay, let's find the probability. What's the probability that people said, yeah, I think Congress should help write some of these standards? What was my percent? 0.34. Very good. Okay, y'all, we need one more piece of information. We need our value, y'all, of Q. So, very good. If P was a 34, my Q should be a 66. Okay, y'all, what we're going to do now is we're going to fill out this table. If you look right here, we have, that means out of the 6 people that we randomly selected, 0, none of them agreed. They all said, you know what? No, I don't think Congress needs to be getting involved in school lunches. And then we could say, well, maybe one person thought that should happen. And then maybe 2 people thought, and 3, and 4, and 5, all the way till we get to 6. So y'all, what I have right here, my friends, is the first part for no people agree, right? We asked 6 people, hey, do you guys think Congress should get involved? And they're all like, no, Congress has other things that they should be doing. Okay, so look, let's do this. Let me grab my calculator again, y'all. I'm going to clear this business out. Exactly what I have written right here is exactly what I'm going to do. So look, I'm going to go my parentheses. I'm going to go 6, math. We're going to go back to our probability. Number 3, we're choosing no people. None of them agreed. Okay, close it off. Open up a new set. Okay, 34%. So we're going to go 0.34. Okay, and again, none of those people agreed that Congress should be involved. And then we got our 0.66. And those 66 people said Congress should not be involved, right? That's 66%. Okay, my friends, I'm going to hit enter. Boom. Here we go, y'all. I'm coming up with, again, I'm going to go ahead and go to 3 decimal places. What do you guys think? 0.082 or 0.083? 83. Okay, right here, my friends, we're going to type in 0.083. Okay, let's do the second one, y'all. Look, we're going to pick the probability that one person feels. So I'm going to go 6, choose 1. One person agrees with that 34%. Y'all, if we got 6 people and one person agrees with that 34%, don't you agree that the other 5 have to be with the other part, the 66? They're the ones that say, hey, Congress should not get involved. Okay, y'all, just like I did before, boom, I'm going to come back here. I'm going to try to make this easy breezy cover girl for myself. I'm going to hit second and enter. What it does, y'all, types out what I did before. And I'm going to say, you know what, Omar, instead of having a 0 down there, you know what you got now? You got a 1. Instead of having a 0 right there, you know what you got, bud? You got a 1. And instead of a 6 right there, you got a 5. Okay. And y'all, I'm going to keep playing this game. So what do you guys think? 0.255? Okay. Okay. Let's keep playing this game, y'all. And we can fill out this table. And what this is doing for us, y'all, it's going to give us the entire set of all the probabilities. Okay, let's change that guy to a 2. Let's change that guy to a 2. And let's change that 5 to a 4. Okay. 0.329. Okay. Probability of 3. 6, choose 3. 0.34 to the third. 0.66 to the third. Okay. Oh man, where's my calculator? Boom, here we go. All right, second enter. Y'all, I like that second enter feature just because it saves me some time, right? When I'm going through this thing here, I don't have to enter everything all over again. All I got to do is just make sure I'm real careful and put my numbers where they're supposed to be. 0.226. Okay. Let's do the fourth one. Okay, 6 choose 4. 0.34 to the fourth. 0.66 squared. Okay. All right, second and enter. Come back over here. That's a 4. That's a 4. That's a 2. 0.087. Oh, come on. There we go. All right, we're almost done, y'all. 6 choose 5. 0.34 to the 5. 0.66 to the 1. Okay, boom. Second enter again. Let's scroll back, scroll back, scroll back. Okay, 5. Oops. 5. And 1. Okay, boom, here we go. All right, 0.018. All right, last one, y'all. Boom, here we go. Okie dokie. Boom. Let's make that a 6. Let's make this dude a 6. Boom. Let's make that guy a 0. Boom. All right, 0.002. And we got our probability distribution. Yo, let me ask you guys a question. Remember, we only had 6 people here. We looked at the probability that out of those 6 people, none of them thought it was a good idea. One of them thought it was a good idea, all the way up to 6. Y'all, I got a question for you guys. If we were to have taken those numbers right there and we would add them all up, anybody know what we'd get? 1, right? Remember, my probabilities, guys, got to add up to 1, right? So if we were to add up all those numbers, it'd get 1, like 100%, right? Boom. Okay, all right, there's some more questions. Okay, let's take a look. Sorry, I didn't even see that. Find the probability that exactly 3 voters think Congress should help. Y'all, 3 voters, what's 3 voters? 0.226. So right here, y'all, I'm going to put 0.226, 0.226. And you're like, hey, Omar, how'd you get that? Boom. I looked at my 3 voters right there. Okay, y'all, what about at least 3 voters? What do you think at least 3 voters, means? At least 3. Does it mean 1, 2, or 3? Or does it mean 3, 4, 5, or 6? 3, 4, 5, or 6, right? At least 3 means 3 or more, right? So y'all, if I'm looking for at least 3, I'm looking for those guys right there, right? Boom. Y'all, I'm just going to grab my plain Jane calculator right here. 0.226 plus 0.089 plus 0.018 plus 0.002. And y'all, I'm coming up with 0.335. Boom, there we go. All right, is there another question? Yes. Okay, part C. Find the probability that less than 3 voters think Congress should help. Y'all, less than 3 voters. Would you guys agree that less than 3 voters would have been those folks right there? Okay, y'all, a couple of ways we can do this. Sorry, let me grab my calculator. Boom. Let me clear this out. We can take 0.083 plus 0.255 plus 0.329. If we add those numbers up, 0.667, right? Boom. And there we go. All right. So y'all, there is, I'm sorry. Okay, there's another part to it. Identify any of the random variables x that might be considered unusual. Unusual would be a number smaller than 0.05. Y'all, let's scroll back over here. Okay, we're looking for any number that would be smaller than 0.05. Okay, so let's do this. No, that's bigger than 0.05. That's bigger, that's bigger, that's bigger, that's bigger. Ooh, isn't that smaller than 0.05? And so is that one. Finding 5 or 6. Okay, so right here, my x values of 5 and my x values of 6. So finding exactly 5 voters who agreed with this, or exactly 6 voters who agreed with this, that would be what we would consider unusual because their probabilities were smaller than 0.05. Okay. All right. Now, y'all, the reason why I want you guys to get comfortable with the graphing calculator is that on the regular calculator, y'all, on this guy right here, it doesn't have this function. Okay, this function, guys, can be found on the graphing calculator or the graphing calculator app or the one that I'm going to use up here. Okay, and y'all, it's going to make this process a little easier. And again, can I go back and use the formula? You can use the formula every time, right? And it's still going to work. I'm going to show you in a minute, y'all, when I think this is going to be a little bit easier to do. So let me show you how we're going to do this on this guy right here. Y'all, I'm going to clear my screen. I'm going to start off with a clear screen. There's something called a binomial PDF. Okay, with the binomial PDF, y'all, it's going to tell me how can I find those probabilities that we did right now without me having to go through and use the formula. Y'all, right here, I'm going to kind of scroll up a little bit. It tells me right here, we're going to start by hitting the second and then the button that says VARS. Okay, so look, y'all, I'm going to hit my second button and I'm going to hit the button that says VARS. Boom. Okay, y'all, what I want to do, I'm going to scroll until I see something. Look at my choice A here, y'all. See, it says binomial PDF. That's what I'm looking for. Okay, y'all, the way this is going to be set up, I'm going to go ahead and hit enter here. Okay, the number of trials. Let's see if we can figure this thing out, y'all. We're going to write down a couple of things here before I do anything else with my calculator. Let's come back and let's look at our problem that we got right here. And we're going to do the first part at least. Look what it says. 30% of consumers. Y'all, can I start right there saying that my P is going to be a 0.3? Because we're talking about the percent. That's my decimal. Prefer to purchase their electronics online. We're going to randomly select how many? 8. That's my N. My N is the number 8. Okay, I'm going to come back right here, y'all, to my part A. Part A says find the probability that the number of people who prefer to purchase their electronics online is exactly 5. Y'all, if you notice right here where it has this thing here, binomial PDF, number of trials, P and X, what they're telling me, y'all, is that we're going to use that binomial PDF. Okay, the first part, the number of trials, that's going to be my N. I'm going to put the number 8. I'm going to put a comma. The next thing is going to tell me, hey, Omar, put the value for P. Our value for P, y'all, was 0.3. Put a comma again. The last thing is going to tell me, how many people are we hoping this happens for? In this case, we said how many folks? 5. That is exactly what I'm going to type in, y'all. So look, let me get my calculator right here. Boom. Look, there it is. Okay, look, the way this calculator set up, y'all, it's just asking me, okay, what was the number of trials? That's my N. We said 8. Okay, what was our P value? Oh, we said our P value, sorry, let me move this over so you can see it. Wasn't that a 0.3? Okay. My X value is the number 5. Okay. And let's just hit enter. Boom. And you see how it typed it right there for me like that? So y'all, I know in my old calculator, the one that I used to use last semester, it came up exactly like that. And I would just put the 8 comma 0.3, comma 5, right? On this one, it just kind of gave me like a format to put it in. So it depends on the way your calculator's set up. Yo, we're going to go to, it looks like 3 decimal places. Let me move my cursor so we can all see it. What do you guys think? 0.04, 046 or 047? 047, right? Boom. And so right here, y'all, I'm going to type in 0.047. Boom. And you're done. Okay. Now, when I get to part B, look what part B says. Find the probability that the number that prefer to purchase their electronics online is more than 5. Y'all, how many people did we survey? Do you remember how many we surveyed? How many people did we ask? 8. Okay, more than 5. Y'all, more than 5. Wouldn't that mean it's going to be 6 people? Or it's going to be 7 people? Or it's going to be 8 people? Okay. Boom. Let's do this. I'm going to come back again. Let me see. I wonder if I can do it this way. Boom. Yes, we can. Look, y'all. We're going to change that. We're looking for the probability that we have 6, 7, or 8. Y'all, all I'm going to do is I'm going to change that to a 6, right? Look, and I'm going to go plus. Let me see what lets me do it again. Second enter. Oh, no, that's not what I wanted. Okay, let's just clear this out. Sorry, guys. Okay, second bars. Let me come back to my binomial PDF. Okay, here we go. Boom, let's hit 8. Okay. Let's see, we wanted 6. Oops. So let me hit this as a 6. Boom. Okay, come down, paste. Okay, plus, guys, I'm going to just do it again. Second bars. Boom. I'm going to scroll back down here to my binomial PDF. Here we go. Enter. Okay, I'm going to change this guy now to a 7. Hit paste. Okay. Plus, I'm going to do that again. Second bars. Boom. Come back down right here, binomial PDF. Boom. And change this guy to an 8. Paste. Boom. Okay, and hit enter. And y'all, again, if I'm going to 3 decimal places, what do you guys think? 0.011 or 0.012? 11, right? Boom. And what we did, y'all, we found each of those probabilities and we added them all up. Does that make sense? Okay. Y'all, look at the next one here. It says, find the probability that the number who prefer to purchase their electronics online is, let's see, at most 5. At most 5 means what? 5 or less. Guys, I put a typo here. This should be a 5, not a 4. Okay. Now, y'all, 5 or less. Y'all, I want you to think about, what does 5 or less mean? It means nobody could want that, or 1 person, or 2 people, or 3 people, or 4 people, or 5 people. Okay. At most 5. At most 5 means 5 or less. Now, y'all, I got 6 things up there, right? So there's 2 ways we could go about doing this. We could do what we did right now, and we could go 0 plus, and we go 1 plus, all the way up to 5. Or on my calculator again, my friends, look, let me come back. I'm going to clear this guy out. Second vars. I'm going to scroll down one more time. Y'all, right underneath the binomial PDF, we have something called the binomial CDF. Y'all, C stands for the word cumulative. Cumulative means we're all up, okay? When we're adding them all up, like it's accumulating, right? So when we're accumulating here, y'all, we're going to go, this is going to tell me, how can I take all the numbers from 0 all the way to 5? Look, y'all, I'm going to hit enter. Boom. Number of trials, we still got 8. My p-value was still at what, a 0.3? Is that what it was? Was it 30%? Okay, 0.3. My x value, y'all, where are we stopping at? We're going all the way from 0 all the way to what? 5. Boom. Okay. Scroll down again. Go ahead and hit paste. Boom. Okay, it should do it right there. Hit enter. And y'all, now I'm coming up with a 0.989. Okay. Now, y'all, what I want to mention here, my friends, is this. Let me do this real quick. Let's go like this, right? Let's do this guy here. Let's do this guy here. Okay. On my calculator, right? If I come back over here, remember our formula? Scroll back this way. Where is it? Boom, right here. Okay. Y'all, if I was doing this guy right here, could I use this calculator to do it? Yeah, I could go to, let's see, where we had 8 people, right? We're going to go PRB. We're going to do number 2. We're going to choose nobody the first time. Okay. Oh, man, Omar, you forgot your parentheses. Okay, look, you can go second insert a parenthesis there, drop another parenthesis there. Okay, boom, you can come back here. What was my probability? 0.3, right? Close it up. Okay, we got to raise that to the power of 0. And then right next to that, we're going to put another parenthesis. If it's the probability it happens is 0.3, the probability it doesn't, 0.7. Okay. And my number here should be some, oh man, what is it? N minus X. So 8 right here, right? Boom. Oops, sorry, it's supposed to be a power. Power of 8, right? Could I do that? Yes. See how long it's going to take me to do it? That's 0. Then I got to do it for 1. Then I got to do it for 2, all the way up to 5 and add them all up. Man, that's going to take me forever and a day. That's why I recommend using this guy right here, because it's going to make it much easier than me instead of having to go through that formula every single time, okay? Look, y'all, let's keep scrolling down a little bit. Let's see what else we got. All right. This one right here, y'all, it says a test consists of 10 true or false questions. To pass a test, a student got to answer at least 8 questions correctly. If we guess on every question, what's the probability that we're going to pass? Okay, so let's think about it this way, y'all. How many questions are on that test? 10. That's my N. My N is 10. Okay. Y'all, those questions are true or false. I only got 2 choices. What's the probability that I'm going to guess correctly? 50%? Everybody agree 0.5? Okay. Now, y'all, in order for us to pass the test, we have to answer at least 8 questions correctly. How many questions are on the test? 10. So doesn't that mean in order for us to pass, if we get 8, we passed? But doesn't it mean also if we got 9, we passed? And if we got 10, we still passed? So y'all, what I'm going to do here, I'm going to find my probability for 8, 9, and 10. I'm going to walk you through the process how I'm going to do this, y'all. Look, we're going to go binomial, PDF, right? The first time, we have a total of 10 questions. The probability that we're going to get it right is a 0.5. For 8, y'all, what I'm going to do for 8, the first one here is going to be an 8. But then, y'all, we could also get 9 questions right. Or we could get all 10 questions right. I'm going to do this, y'all, 3 times, and I'm going to add up my numbers. So look, let's go slow to make sure that we're all good here. Boom. Let's clear this guy out. Boom. All right, y'all, look. Second in VARs. We're going to scroll down, Charlie Browns. Here's my binomial PDF. I'm going to hit enter. Okay, we got 10 questions. Boom. My p-value, 0.5. Boom. My x value is an 8. Okay, we're going to go paste. Boom. And then, y'all, I'm going to go plus. And I'm going to go second VARs again. And I'm going to scroll down one more time, y'all. Boom. And I'm going to do the same thing right here. Oops, sorry. but I'm going to change that 8 to a 9. Enter. Okay. Plus, y'all, I'm going to do that a third time. I'm going to scroll down, Charlie Brown. Boom. Right there. Except now my X value is going to be a 10. Boom. Okay. So look, y'all, if I scroll back here, it should have all three of them, right? The first one where it's 8, there it is. Second one where it's 9, there it is. And the last one with all 10 questions, we're going to hit enter. Boom. And y'all, if I go to 3 decimal places, would you say 0.054 or 0.055? 55. Boom. Oops. Sorry, guys, my pen's dying on me. Boom. Here we go. 0.055. Y'all, let me ask you a question. Are you guys feeling more confident or comfortable with the calculator a little bit? Y'all, it's just like anything else. Anybody here learn how to drive recently? Anybody not know how to drive? Let me put it that way. Anybody here not driving yet? We're all driving? Okay, the first time you learned how to drive, was your mom yelling at you? Your dad yelling at you, right? Your uncle, whoever, somebody was yelling at you, right? My dad was yelling at me. What are you doing, right? I don't know, Dad. It's the first time I'm driving. Give me a break, right? So, y'all, the first time you're doing stuff, it's always difficult. It's always difficult. The more you practice, the easier it gets. Y'all, real quick story. My brother went to a private school in San Antonio because he thought he wanted to be a priest. And so one weekend, my mom decided to fly to San Antonio and spend the weekend with him, right? We lived in Edinburgh. She flew out of Harlingen. And afterwards, my dad used to work in Elsa. He was a counselor at the junior high there, right? My dad and I drove to Harlingen. He goes, okay, we're going to pick up Mom's car and we're going to come back home. Y'all, I was in 6th grade, so I was 12 years old, and I drove my mom's car from Harlingen all the way to Edinburgh. I don't know what my dad and my mom were thinking, right? But 12 years old, driving my mom's car. Were you driving at 12? No, right? 12 years old, y'all. Why were they doing that? I got no idea. But I told my parents that story like a year ago, and they're like, we didn't do that. I'm like, yeah, I drove the car. Anywho. All right, let's keep working here, y'all. We're almost done. Find the probability that an individual is left-handed. Oops, sorry. Is 0.180. Y'all, first thing I'm going to do right here, my p-value, 0.180. Okay. We have a class of 57 people. We are looking for the probability that exactly 5 of them are left-handed. Okay. Binomial PDF. Y'all remember, the first number is my n, the second number is my p, the last number is my x. We got 57 folks. Probability that you're left-handed, 0.18. We're looking for 5 out of those 57. All right, boom. Let's come back and let's do this to this. All right, second bars, y'all. Scroll down, Charlie Brown's. Boom, there you go. Okay, 57 folks. Probability 0.180. X value 5. Boom. All right, guys, I'm going to go ahead and go to 3 decimal places again. 0.026. Oh, come on. Sorry, guys, my pen's freezing up on me. 0.026. There we go. Okay. All right. Y'all, we got a couple more. Let's see if we can figure out this next one here. It says 59% of U.S. adults think that civil rights for Black Americans have improved during their lifetime. We randomly select 10 people. Find the probability that the number who thinks civil rights for Black Americans have improved is exactly 1 and exactly 4. Okay, first thing I'm going to do here, y'all, my p-value, 0.59. We randomly select 10 people. My N is 10. Okay, let's do part A. Exactly 1. We're looking for the probability that my X value, guys, is going to be equal to 1. Okay. My N is 10. My P is 0.59. And my X value is 1. Okay. All right, let's do it again. Boom. Second bars. Boom. Binomial PDF. Boom. Here we go. All right, we got 10. We got 0.59. We got an X value of 1. We're going to paste it. We're going to enter it. And y'all, I'm coming up with 0.002. And there's a second part to that question, y'all. Part B says, what about exactly 4? Okay, we can do that too. We're going to do the same thing. Binomial PDF, 10, 0.59, and now with a 4, right? So let me see, second enter. Yeah, it's going to change that dude right there, y'all, to a 4. Boom. And I'm coming up with 0.121. Right? All righty. Y'all, let's scroll down. We got a couple more to do, and then we can do something a little different. Sorry. Let's see what we got here, y'all. It says 45% of consumers say that it's important that the clothing they buy is made without child labor. I think that's probably a good idea. Okay. Y'all, before I get started, my p-value, I already know this, 0.45. We randomly select 17 consumers, so my N is a 17. Okay. Part A says, find the probability that the number of consumers who say it's important that the clothing they buy is made without child labor is exactly 7. Okay. Look, y'all, they're telling me exactly what to do here. They're telling me right when X is 7. So we're going to go binomial PDF. 17 people that we asked, 45% agreed, and we're looking at 7. Okay, boom. Second enter. Oh, let me change my numbers again. That's really a 17. That's really a 45. And that's really the number 7. Hit enter. Y'all, I'm coming up with a 0.184. Okay. Okay. And part B, y'all, says, what about at least 9? Okay, y'all, how many people did we look at here? How many people did we survey again? What was the total number? 17, right? Okay, y'all, at least 9. Does at least 9 mean 9 or 10 or 11, all the way up until we get to what number? 17, right? Okay, let me ask you guys a question. If we were to take the probability that none of them agreed with this, right? 2, okay, 8, 9, all the way to 17. Do you guys agree we'd get the number 1? If we took all the possibilities and we added them all up, we should come up with the number 1? Okay. Y'all, what we're looking for right now, we're looking for this. We're looking for 9 all the way to 17, okay? Now, the reason why I'm telling you this, y'all, is that on my calculator, it would be easy for me to find this part. If I knew what this number was, even though I'm looking for this number, once I find the number in red, couldn't we take 1 minus that number and it would leave me with this guy right here? Okay, y'all, the way we can find this number in red is if we go with the binomial CDF, because it's going to accumulate them with 17 people, a probability of 45 all the way up to 8. Again, y'all, this is one of the biggest reasons why I want you to get some comfortability with this guy right here. Okay. We got 17 people. The probability was 0.45. We were going from 0 all the way up to 8. Boom. There it is. Okay. I'm going to hit enter. Y'all, that number, according to what I got here, looks like a 0.663. Okay. So y'all, this number right here, I'm going to kind of draw like a line through it. Boom. That number is 0.663. If I want to find that number, the one in purple, couldn't we just take 1 minus 0.663? So we did 1 minus 0.663. I'm coming up with a point. And y'all, to me, that was easier for me to do calculation-wise than to say, Omar, do it for 9, do it for 10, do it for 11. Keep playing that game all the way until you get to 17. I don't have to do so many steps. I mean, I could do it. It's not that I couldn't. I could, but it was easier for me to do this other way. Okay. Y'all, when I took statistics back in the day, I took it like in 1994, 95, something like that. That was a long time ago, y'all. I don't remember what we did, right? I don't remember what we did. But I'm hoping that my professor didn't have me do all that kind of calculation, man, because why? Small mistakes add up, right? You put the wrong number, you hit the wrong button, right? My big old chorizo fingers, I hit the wrong button. Man, the whole thing is off. At least here, I have a better chance of not making a mistake, okay? Look, y'all, there's a part C to it. Part C to it says we're going to look for the probability that they are what? Less than 10? Less than 10. Doesn't that mean 0 all the way up to 9? Y'all, if I'm going to go from 0 all the way up to 9, again, I can come back one more time, my friends, and say, look, we're going to use our binomial CDF, 17 people, 45% agreed, and we're going to stop at 9. We're going to go from 0 all the way to 9. So y'all, look, I'm going to come back here. We're going to go second bars. Let's scroll down to our binomial CDF. We got 17 people, 45. Boom, let's just change that guy to a 9. Okay, boom, let's hit paste and hit enter. And y'all, it looks like I'm coming up with 0.817. There we go. All right, so y'all, this is the last part here in 4.2. When we have binomial distributions, y'all, we're able to find things like the mean, which is the average, right? We're able to find the variance. And people ask, Omar, what do we find the variance for? Y'all, remember, the way we find the standard deviation, it's the square root of the variance. The standard deviation tells me on average, how much is it going to change by? Okay, so that's why we go through that process with the variance. Let's take a look and let's see if we can find some things here and figure out some information. So y'all, what I'm going to do real quick, like, boom, come back here. Let's go new. Let's get this guy right here just so that we have access to it. Okay, so let's take a look and let's see what we can do here. Look what it says. 74% of adults in a certain country believe that life on other planets is possible. Y'all, I'm going to write something down right here. Boom, P, 74%, 0.74. We randomly select how many people? 5 people, and ask them whether they believe life on Earth, life on other planets is possible. The random variable represents the number of people who believe, all that kind of good stuff. Okay, can we find the mean? Look, y'all, I want you to look at my formula for the mean. The mean formula just says take your n value, multiply it by your p value. Okay, so look, 5 times 0.74 times 0.74. The average, 3.7. Y'all, somebody asked me about this last semester. Omar, it says rounded 2. Well, I only got 1, so I can't put 2. Okay. Find the variance. Y'all, look at the formula for the variance. We're going to take n times p times q. Okay. So my formula for the variance, the sigma squared n, 5, times p, 0.74. Y'all, question. Anybody know what would our q number be? 74% chance it's going to rain. 26, right? Boom, there you go. All right, let's do that. Okay, so look, we already did the n times p. Look, times point, we said 26. 0.96 right here. Okay. Now, we're going to find our standard deviation. Y'all, the way we find the standard deviation, we're going to take the square root of the answer that we just got. You say, why the square root? Look, it's got the square root on it. Okay. Let's do this. Let me take my calculator. Look, y'all got 0.962. Hit the square root button. Did you guys come up with 0.98? Right? Or look, if you go 0.96, boom, square root it, 0.98, right? 0.98. Okay. Now, let's see if we can interpret the results. Okay, let's do this. Boom. On average, what should these up here y'all refer to the average? The top one, right? The mean. Okay, on average, what did we get for average? What was our number? 3.7. Y'all, right here, I write the number 3.7. 3.7 out of every 5 adults in the country believe that life on other planets is possible. In most sample of 5 adults, the number of adults who think life on other planets is plausible would differ from the mean. The differ is my deviation. What was our deviation? 0.98. That's all you got to do, tennis shoe. Okay, look, let's do this, y'all. Boom. Stop recording.